So welcome to this session about URP. You will see we start by a small history and where we are with URP right now. And we see a live demo of the new URP samples. And I will finish with kind of an overview of everything which is coming in Unity 6. And I'm Mathieu Muller. I'm a product manager for URP. I was product manager for HDRP, but now I cover the two so that we have more uniformity, hopefully, across the board. And I've been working in real-time 3D for 22 years. Started as an engine developer, and I've been at Unity for 9 years. Starting as a field engineer and product manager for film and TV.
Yeah. And I'm Jonas Mortensen. I'm a technical artist. I finished my studies as a computer scientist 4 years ago, or 5 years ago, and I've been at Unity since. So working closely with the URP team, I'm building samples and tutorials and learn projects, and then also working with developers on our workflows in URP, prioritizing features and making sure that they work from an artist standpoint and fit well in artist workflows. So yeah, been there for 4 years now.
So about 10 years ago, we introduced Unity 5. I don't know, who was using Unity 10 years ago here? Wow, that's a lot. And so you remember, we introduced PBR, the command buffers to inject in the pipeline, the new Lightmapper, and all these things. But in reality, it took like 3 to 5 years so that everybody moved from Unity 4 to Unity 5, that the product matures and so on. And then after 5 years, we started to introduce, like it was 2018, I think, when we started to mature, and then we introduced the packages. I don't know, like for the people who use Unity for a long time, if it's like me, but like 2000, which is the best version of Unity in the entire life for you? Like to me, 2018 was a great one. I don't know if 2017? Unity 5.0? Oh, wow, okay. Like I've heard a lot of studios saying 2018 was the best. It was just like the end of the cycle of Unity 5, the real cycle. And then we introduced the package manager, so we could say, hey, we can add all these technologies on top, like the SRPs. And now it's been another 5 years since we started this. And somehow it's funny, because I've been saying this for years, but we have been building Unity 6 for like the past 5 years, if you really look at it. So I just wanted to clarify this, maybe this morning. And why there is a slide with the game content. There is a lot more games made with URP here. It's just really, I want to thank you as a product manager, because if URP is here, is because to mature, it required all of your feedback. Like each time there is a game shipping with URP, it makes URP production ready. So thanks a lot. Who is using URP here?
Nice.
Okay. Who has shipped a game with URP? Okay, so thank you. Thanks a lot. Yeah, let's go to the next thing. So about 5 years ago, actually 6 years ago, when I was visiting studios, like the feedback about built-in was, okay, the rendering is a black box. Then we were supporting a lot of platforms like we do today, but it was like it's neither really like optimized for the high end, and it's not really optimized for the low end. It's kind of like in the middle. And then third, if you're an artist, you have to, it's like a box, like it's a Lego box where you have Mrs. pieces, and then you have to buy the extra ones to build your stuff. And at the same time, the industry, I don't know if you realize, but the industry changed a lot in the past 5, 6 years. So for example, just XR made mobile even more complicated. Like you have more pixels, wider field of view, more vertices. So basically, it's not about more features, it's about more things with the same hardware. While the high-end became even more high-end, like the things went like this, like the new GPU, the new consoles, the new generation of consoles. So here we are today with Unity 6 and what we've done. Scriptable render pipeline to open this black box. And then 2 pipelines, one which is optimized for mobile first so that it can have the maximum reach, and at the same time being very customizable. And on the other side, HDRP, totally optimized for compute architecture and PC and consoles, and offering an off-the-shelf experience for artists. What we did not, I think, did very well was like a lot of things that could have been shared a lot more between the two pipelines. And since about 2 years, 3 years, I would say, we have been trying to move a lot of things back to the SRP core, and especially on the artist side, to try to really align a lot of the workflows. It's still not totally done, but it's on the way. Same for the core of the engine. We try to share more data structure or more configurations. And I will talk about this a bit later. Who is using HDRP here? OK, oh, yeah. So, and I have a session about HDRP. If the others who are not using HDRP want to come, you're welcome. It's at 6. So we went from the lightweight render pipeline idea at the beginning, which was like to have a very small engine, super customizable and very lightweight. But then it was really missing like a lot of things to still be very usable off the shelf. So it moved to become universal. And in the past years, we had to kind of like catch up and add back all these features from built-in. I've been told that this slide is not very clear, so I will go through it. We see that we still have a few features which are not in URP, like SSR, auto exposure, post-process alpha preservation, and surface shaders. So each time people like you complain, and it's always very often about this, and we can discuss after this if you want. And then we address some of the disparity on Unity 6, like with object motion blur, custom post-process, and TA, which has been backported to 22 LTS. But sometimes I think we forget about all the unique features that have URP, so I wanted to list them all in one slide. So first, of course, the access to the source code, the custom renderer features, the compatibility with dots, the SRP batcher. The SRP batcher, I don't know if everybody realizes the power of this. Like, you know, you were maybe used to use material property blocks, which are not compatible with SRP batcher. But like, actually, it's like SRP batcher does better than actually using material property blocks. So forget about it. And in most of the time, it's faster than even hardware instancing. So it's actually a very magical component. Forward Plus, Shadow Graph as first citizen, VFX Graph, Clear Code Shader, SRP Lens Flares, FSR Upscaler, and Rendering Debugger. And in the last part of this presentation, I will present all the things coming in Unity 6. But let's start with, and I put it in Unity 6, but it's actually available for 22 LTS, with this amazing sample. I don't know who liked the benchmark scene at the beginning when you create. Like, did you find it useful? Kind of, yeah.
Two found it usable.
Yeah, and we really, like, one of the biggest problems when you start with URP is like, you can do so many different things from XR to make a game on Switch, PC, and consoles, or make a mobile game. And how do you exactly start? You know, what is the template for this? So we wanted to create a very good template that is already set up, which is a commitment from ourselves that we commit to all these platforms. And at the same time, we wanted to have a way for you to learn how to use these features in different contexts. So we are super happy. It's a big, big news and a lot of work from the team of Jonas and people. And by the way, before we start with the trailer and the demo, thanks a lot. We started to share it on the forum a few months ago, and it was super nice. Jim said that this morning, and David, that, you know, we kind of make one. We make the engine, you make the game, but we all ship the game together, basically. And it's the same for the templates. Like, we had a lot of feedback and people sharing, hey, you could optimize this doing that. So we even learned good tips on our side. So thanks a lot again for that.
Yeah, thank you all so much. We're going to quickly announce it first with a trailer video that we made. So that's going to come here. right.
Oh.
So now I wanted to just spend some time and actually open the project and go through some things that I think are interesting about it. When you open it up, yeah, as Mathieu said, it was available in the forums and have been for a couple of months now. But now, as of day before yesterday, I think it's actually released. So if you go to the Unity Hub and create a new project using 2022, you'll be able to select the project here from the templates and just start digging in yourself and tear it apart. Really hope that you'll dive deep and use this as a learning resource for learning URP as well, which is something that we of course try to do all the time. Make sure that you realize how powerful the tool that we're building is. And one of the elements that we're including in the project is the in-editor tutorial, which you see here on the right. And that's going to have sections for important aspects about URP and even have guides on how to extend URP, because we built the sample to make sure we cover the entire feature set. And that includes extensibility and customizability. So when it made sense, we built custom features for the sample, all within the limits of the package. So it doesn't involve any custom package changes. But we use the APIs that are available and exposed by URP to extend everything. So yeah, I really recommend doing a deep dive and taking a look at the tutorial. I'm just going to close it for now for this manual walkthrough. And it opens up in the terminal, which you also saw on the video here. And this scene has two purposes. The first purpose is to function as a look dev environment, like a very neutral lighting, and we have the Unity material ball in the center here. But it's mainly meant for you to test your own assets. So I can quickly disable this material ball, and then I've prepared this giant mushroom tree, and I can then take a look and see, okay, how are my materials set up correctly in URP? Is the lighting working, and how is it interacting with the pipeline? In every scene, we have a first-person controller as well. So I can just let me see here, quickly jump into play mode and see what everything looks like in game, and walk around it and be in awe of the beautiful mushroom tree. All right, and then when I'm done looking at my assets, I can move up to the second platform. And this takes me to the second requirement of the scene, which is also the reason why we named it the terminal. So as you saw in the video, we have 3 additional scenes apart from this one. And here we have one room for each of the scenes, and we have iconography to kind of hint at what's inside the rooms. And then the design is basically that you can explore this area like a museum, and you can basically interact with the space. So I'll just use the garden as an example. We see the iconography here, and as I enter the room, we have these screens on the walls, and they will turn on and kind of give a sneak peek into whatever is behind this area. And we have some nice shader graphs for doing like pixelation effects when you get up close, and also some simulating some data being lost in pixelation and stuff, just to show different tricks you can use in shader graph. The way this is done is actually that the scene is enabled off screen. So we have 2 scenes enabled now. You have the terminal and the garden. And then we have an additional camera in the other scene actually capturing everything that's on screen. And the easiest way to show that is by using the frame debugger, which is a tool I really wanted to highlight. It's something I use daily in my work to be able to make sure that the pipeline is behaving as I want it to. If you're optimizing for performance or just configuring in general, it's a really powerful tool. And you open it by clicking this tiny bug icon here. And as I click it, it'll open the frame debugger, and we can see that the game is now paused. And I now have this view where I can see what's on screen, but also traverse basically the passes that have been injected, this frame, on the left. So you can see here that we're running 2 iterations of the URP render single camera function. And one is for the main camera, and one is for the screen camera. And the screen camera is then this camera that's rendering off screen the contents of the garden. And I can select this and adjust my levels here. And we can see that this is actually what ends up on screen in the final case. And I can do a deep dive, and I can see, okay, what's actually happening here. We'll see that we're getting a depth normal pre-pass. Let me just readjust the levels here, which is then used by the SSAO, and all contributing to building this final frame. And then this final frame is then eventually sampled in here. And I could let's see if I can actually do it. So in the opaque pass, I would expect so the screen, okay, I can't find them, but the screens are rendering, and then they're sampling this texture that was rendered by this previous camera. And that's how we make this effect of rendering basically an additional scene in the space at the same time. And then when you're done exploring the effect, you can actually teleport to the space. And the way you do that is you have your crosshair in the middle of the screen. I can place that on top of the Unity logo, and everything will start to dissolve. And I can look away to cancel it. You'll see that there's this loading bar around the Unity logo, and if I look away before it ends, I'm all good. But if I stick around and look for it for longer, the entire image will dissolve, and I'll then dissolve back seamlessly into this new space. And this is the first scene, the garden, which we built to basically showcase URP's ability to do stylized but still high fidelity rendering. So it's still PBR, it's still high quality shaders, but all the shapes and textures have some kind of style, right? They're like painterly. We were very much inspired by Overwatch and even Blizzard movies for this, where the lighting model is advanced, but the shapes are stylized or simplified and exaggerated. The space also shows URP's capability of rendering many lights. So you see we have all these tiny lanterns. All of them are real time, and we're able to render this thanks to a Forward Plus, which I'll dig a bit deeper into in a second. And then you can explore the space. There's a room over there that I'll let you explore on your own. And when you're done, we have a similar setup here back in the starting area, where we can now see the terminal being loaded, and the Unity logo shows up, and I can get back and continue my exploration by just interacting with the control panel. Yeah, so as I said, the garden uses a lot of lights, and I want to showcase that, but I also want to show the fact that all the scenes are built very isolated. So, you might want to build this intricate, let's call it vertical slice of a game with all the 4 scenes, but you might also just be interested in building only the garden because you want to test something specific. So that's why we build every scene independently. And in the build settings, you'll be able to just disable the scenes you don't want. We also have a benchmark scene you can build to just get some quick performance numbers. But then I can just disable everything and only build the garden. And that would work perfectly fine. So if I just open the garden quickly, it's usually easier to do it like this, so I can test stuff that's specifically about the garden. And it has a first-person controller in here as well, and it works completely by itself, which I think is cool. Now, back to the lights. I said that this scene tries to show off URP's ability to render a lot of lights. And I'm going to talk a bit more about that. We're using Forward Plus, and Forward Plus is a really cool tech. It basically allows you to run forward, which has a lot of flexibility. It has a lot there's a lot of good reasons to use forward, especially if you want to do advanced shaders. But previously it had the drawback of being very limited in the number of lights you can have affecting your object. So if I quickly go into settings here, and I take my renderer, you can see it's running forward. Plus, if I change it back to forward, if you just keep your eyes on the small lanterns in the foreground here, they should come off as the light limit of the gravel texture is basically exceeded. And the best way to show that, or to debug that, is by using the rendering debugger. So if I go to Window, Analysis, this is separate from the Frame debugger. This is a different debug tool, and it's mainly focused on debugging render artifacts or like issues with how your image is looking. You can use the rendering debugger for that. The cool thing about the rendering debugger is that it's also available in the build if you do a development build. So all the features that are supported by this rendering debugger view, you can pull up in a UI on the actual player and do the same things. So yeah, it even has performance stats, and these stats will also be available on the device. So if you do a development build, you just tap it with 3 fingers, it will show up the window, and without building any systems, you'll have an easy way to get performance statistics.
And be careful, because the display stats, they only appear on play mode. So sometimes a lot of people are missing it, but it's only on play mode or in the build. So it's
exactly.
useful.
So yeah, right now it's not visible. I enter play mode, and it shows up. But what I wanted to show with the rendering debugger is the lighting complexity material override. So it's available here in the material override section. I pick lighting complexity, and now instead of seeing the actual rendered colors of the scene, we're now getting these tiles with numbers inside them. And the numbers basically represent how many lights are affecting this pixel on screen. And what we can see is that it's horrible. The gravel, which is a giant mesh that covers the entire outside area, is being affected by 9 lights. And that's the limit, so a lot of the lights are just being called and are not actually affecting the geometry. The lights are very small, so it's actually a bummer, because no single pixel needs to be affected by that many lights. It's just the fact that regular forward doesn't know the difference between the area the light affects and the object affected by the light. So it just has to be very brute force and send all the data to the geometry. But if I now change back to forward plus, let's see, it's here. You'll see that it's a different story. Right now, there are no more pixels being affected by 9 lights, and most of them are actually only being affected by 2 or 3. So in cases like this, where you have a lot of lights affecting large geometry, forward plus, even though it actually allows you to render more lights, because if I now disable the rendering debugger, you can see that all our lights now actually come back. So in theory, we're rendering more lights, but it still can be a performance optimization because we're not considering lights that are actually not affecting this specific part of the screen. And what's really interesting about it as well is that it makes really obvious how the range of a light can affect performance. So if I take this lantern as an example, it's a point light, and you can actually kind of see its area of effect, right? You can see this circle here around it. And this is strictly determined by the range. So you can see that in this area, it's lighting complexity 2, and it goes to 3 as it enters the range of the light. And if I reduce it, it basically becomes cheaper. So that really is an argument for the fact that you have to tweak your light ranges. So for every single light, you have to basically consider how intense is the light and how small can my range be in order to still get the effect that I want from my light. Of course, this is not very easy to configure while you are in the debug mode, but if I go here and let's say my light is not very intense, like 0.1 maybe, so it's still there in the center there, but I can probably go like to a range that's all the way down to 0.72 maybe without getting much of a difference. And then of course I can increase it, and this will increase my lighting complexity, but it won't change the image actually because of the fall off of the very low intensity light, it's not making a difference. Another light performance considerations we had is that with all these lights, you might be tempted to make them all shadow casting, but shadow casting lights is kind of an expensive feature. Shadow casting real-time lights, that is. So you wanna have as few of them as possible, and we only have 6 in the scene actually, which might sound weird with the amount of real-time lights we have, but that's because we use cookies wherever we can. So if we have this lantern in here, for instance, you can see if I select the point light, this is actually not casting shadows at all. But even though it's not casting shadows, we get this interaction with the environment that completely follows the shape of the light. And it's actually a pretty complex object to light, right? Because we have these big flat areas that cast complex lighting, and with a point light, it's very hard to capture that. But when we do this method of using a cookie, it really sells quite well. And you can see the cookie is assigned here, and if I just remove it quickly, you can see that this is what it would look like without it, not anywhere as interesting and not anywhere near as convincing as having the light cookie. And the cookie looks like this. The thing is, you have to render a unique cookie per light, because it's depending on the light shape. And the way these are made is that in a DCC, for me, I use Blender. I just pull the asset into Blender and make the changes I need, put a camera at the center of the light, and just render a black and white image of this shape. And then I blur it a bit in Photoshop, and now I have what looks like very complex shadows, but it's actually just a light cookie. Yeah, I'll move on now to the Oasis, which is the second scene. And for this one, we tried to go for a bit more photorealistic look. We have more realistic shapes. We have this inside area in the tent here that's less stylized. And we used SpeedTree, or the SpeedTree team helped us build these awesome trees that have convincing interaction with lighting. They have subsurface scattering, so if you look on the sun here, you can see that the light is leaking through.
Maybe remove the grid.
What?
The grid, maybe.
Yeah, so this is where we have one of the customs things that I talked about, where when able, we wanted to show how to customize URP as well. And we built this screen space reflection effect. So if you see here, if I look at the water, we can see that the cliffs here are actually reflecting on the water here. And screen space reflections are not in URP by default, but there are a lot of systems that makes it very easy to build features like this on top of URP. So you can see that the reflections are working, and they even are fading with the reflection probe, because a typical issue with screen space reflections is that once the screen content goes out of screen, you miss the reflections. But here we do like a subtle fade to the reflection probe. So we get less precise reflections when nothing is on screen, but it's still there. And then as the data becomes available, we kind of fade it back into being more accurate. And the way this is done is using shader graph and a bit of HLSL. So if I just select the material, and I guess this shows how you would interact with the sample, or like how we want you to interact with the sample, is if you see something that's cool and you want to figure out how it works, it's just a matter of taking the material and opening the shader and just passing it. And what we want to do is annotate everything as much as possible. We're still in the process of doing that, but we want to make sure that all lines of code, all shader graphs are annotated and have comments where it makes sense. They're already pretty well structured, so I can see here that we have the ray-matched reflections section, and this is where the screen space reflection is happening, and we have a node that's called ray-match, a custom function node, which just calls this HLSL script. So of course, it becomes a bit more advanced. You have to know about HLSL, and you have to know, well, about ray matching in general, and you have to know the theory behind screen space reflections in order to get an idea of how it's working. But once you have that, you can basically take this code and copy paste it into your own project, even without knowing actually. But if you want to understand how it works, you can do that as well. So you have the ray match function, and you can get an idea that it's getting an origin and a direction, so array basically, and then through the loop it pushes this origin point, so you get distinct steps along the ray, and then you test that against the depth buffer, and yeah, it's another topic, but you're able to deep dive into this and see how it works and pull it apart or just pull it into your own project. That's the aim. Now the last scene is the cockpit. And for this, we thought it was a good opportunity to make something that's built on timeline. So it's easy as a graphics team to just build a sample that's exclusively graphics and has no gameplay. And we wanted to kind of venture outside of our comfort zone a little bit, so that's why we did the teleportation effect, which you could argue is like a gameplay thing. And then we also decided to use timeline to basically author this entire scene here. So you can scrub through everything, and everything will update, and you can see and pull everything apart and see how we use animation and how we use particle system and make sure the particle system is synced. Yeah, I guess, and then yeah, I'll talk about the shaders as well. So this sample is built to run on the Quest, so we're running 72 FPS on the Quest 2, and we wanted that from the beginning to be able to show that URP is a really good pipeline for targeting those devices. And it can be hard to hit the numbers on those, and the way we decided to do it here is actually to build custom lighting onto our shaders. And this is all built with shader graph as well. So if I just open this example shader here, we can see that it's actually targeting, for those of you who are aware with shader graph, it's targeting the unlit material, even though it does interact with the light of the scene. But then we have these individual sections, one for applying fog, one for doing light mapping, and we have one for doing the actual toon lighting, which is a subgraph you can then dig into and find out how the lighting is built. So here we're just building custom lighting on top of the unlit shader graph in order to get the performance and the look that we want for this specific scene. Yeah, so that's most of the projects. I wanted to just quickly do a comment on build times. So build times, as many of you who work with URP probably know, is something that can take a while in URP, and we're working on how to fix it. But for now, I guess the biggest tip I can give is to build with as few quality levels as possible. So if I just open the project settings here and look at the quality settings, we can see that we have 2 mobile quality settings and 2 PC quality settings. And by default, only one of each is enabled. So that means if I build to iOS, I'll only build the mobile high quality setting. And that's not because you might want to do that in an actual release. You probably want to include both. But when iterating and just testing your game, you really want to do this. You really want to limit the amount of quality levels you're building, even limit the amount of scenes that you're building, just to reduce the amount of shader variants that are in a project. So for me, on this M1 Mac, building all the scenes on mobile high was 5 minutes. And then including mobile low and building both was 15 minutes, clean build. So that's like a 3x speed increase of just including another quality level. So you need to be really mindful of that. Of course, if your build times are longer because of a different hardware, then that 3x becomes even worse, right? So just a quick tip about general URP development, but also if you want to build the sample, remember to include the quality level that makes sense for the device that you're building to. Yeah, I think that's what I wanted to show.
That was very good. So we regret the old benchmark sample now? Anyone? It's okay? We don't bring it back, right? The old stuff, okay, cool. Oh yeah, we have to thank.
Oh yes, sorry. So, yeah, this wasn't all me building this scene. We had a team of very talented people from within Unity, but also we had some help from outsourced studio. So big thanks to anyone who helped. It's a big effort to put something like this together. There's a lot of different art styles, which means different artists, and a lot of technical stuff, and of course the URP team as well for building the tech. So big thanks to anyone who was part of it.
Yeah. And what is great is like it's a real contract for us, you know. We're gonna update it at each version. That will be our reference for build time, for performances. So that's a real big change, I think, about how we deliver URP. So as I was mentioning, URP is like at the core is really to be optimized for mobile hardware to be able to scale up and to be extensible. And that's been a lot of effort from the team in Unity 6. So first, the GPU resident drawer that we've seen this morning on the demo, as we were mentioning, it's available on URP. It's deactivated by default at the moment. So if you download the latest version of URP, it's already there, but you can activate it. Reason is like it's limited to forward plus and for compute-capable mobile devices. But there is an auto fallback if you don't have a compute-capable device. And what it does, I really recommend if you really want to know the ground of like the deeply what it does. It's using a system which is inherited from DOTS, which is called BRG, batch render groups, which allows to basically massively treat your draw calls and send them very efficiently to the GPU. And there is a very good blog post by Arnaud Carré, who was one of the fathers of the BRG, who came from the demo scene and really thought about how to optimize to hell this communication. There is always this fight in the teams between the people who want to optimize the CPU and the GPU and saying, I will make the CPU better so the game is better, and vice versa. So if we see examples, what is great with this system is really like, it's kind of magical. You turn it on. For example, on the garden scene that we've seen, just going one version on top, on iOS 8.12, 22 milliseconds of CPU time. You just turn it on, and it's 15 milliseconds CPU time. On Quest 2, same thing. It's like 1.5x performance improvements. Then there's a second thing, which was like we introduced FSR, so an upscaler. So basically, you render at a percentage of the frame, and then you scale it up, right? And there were some algorithms in the past which were not so smart, and then the upscaling was a bit obvious. And in the past years, there were a lot of progress in the industry with a lot of upscalers. And in URP, we introduced the FSR upscaler, so it was done in partnership with AMD. It was one of the first upscaler for mobile, and yeah, pretty advanced. But we really, like, one of the top asks was to have a temporal upscaler for URP. But the problem with temporal upscalers, one, it needed a TAA, so it came lastly. And number two, it's very hard to find an upscaler on the market which really works on a lot of devices. So we decided to have our own technology that we called STP, Spatial Temporal Post-Process, and basically which looks at the previous frames looks through the frames and use accumulations to like, if we want to simplify, to recreate the pixels which are missing when you upscale. And it's quite magical, as you've seen this morning. You almost see no difference between a 2K image and a 4K image, for example. And it will be very important for all kind of application on any platform. Same thing. It's like I was mentioning before, we made the mistake a bit in the past, maybe to have too many things which are not compatible with the pipelines. We really try like these features to be cross-compatible. Same thing, one of the needs is to require compute-capable mobile devices. But again, no content change is needed. Another aspect is really also what I mentioned at the beginning, that creating a render pipeline for mobile hardware and creating a pipeline for a PC or console GPU is not the same thing. And the first big difference is the fact that on the GPU, it has its own RAM, and then you exchange between the CPU and the GPU, and this is the way it works with a discrete GPU on PC and consoles. On the mobile, you share the same RAM, and this has big consequences on your performance and on your power consumption. And then on mobile, on mobile and not just mobile, actually, on multiple platforms now, you have tile-based rendering. And basically, like the idea is like to be not efficient, you can grab the entire frame, which will grab all the tiles, and it's very expensive. Or you can try and should do as much as possible inside of a tile. So when you render, like most of the work should have happened here. And if you start to do advanced effects, it becomes very complicated to access. You tell me if I'm wrong, right? And to access this tile-based these tiles. And so we introduced native render passes, which allows to for your customization to access these native optimizations on mobile. RT handles so that you can manage the multiple cameras with different resolutions, and that's it. So, in order to manage all this complexity and well manage your memory, it's very important that, like, anytime you are touching at the memory, it has to be very efficient, especially when you're working on the graphic side. And so, when you write a pipeline, it's very hard-coded. You know, like you do this rendering, you have the transparent. You have, for each effect, you write each one. Oh, I need this resource, and then I move this in the code because now I'm doing this in another way. So a pipeline is really like a sequence of things, and each time you insert yourself in that, if we change anything, the resources that you need will have moved maybe, and it will break the next time. If you combine this with another plugin, it will be the same. And the only way to, and lastly, like your memory, you might have used a buffer for some time that you did not need later on your pipeline, and you could have actually reused that memory later. And in order to do this and not break, the best way to do it is to create a graph. So you have a clear contract with an API, a bit safer API, where you will say which resource do you need for your passes and which resource you export. And then we create a graph at runtime to finding all the dependencies because all these resources and creating this dependency graph. And this will allow to, first for you to visualize exactly how you're using your resources, how we are using our resources, and how you can update them. So this is the image of the visualizer, just as we've seen for the debugging renderer. This is one of the analysis tools that we have, where you will be able to see exactly how you're using your memory, and it's very powerful. So it's coming to Unity 6. It will be by default that we want really this to be the future, because it will allow us to extend our pipeline without breaking you, and you to extend your pipeline and actually mixing with other people with less breaks. And down the line, it also allows to better manage the memory underneath and better optimize it for mobile. I was telling about also uniforming things, like something we introduced in HDRP where the volume was a volume system. And the volume system, it allows to set up your games being global and then having overrides if you put another volume with higher priority, or putting a collider, and this, when you enter this volume, it will blend or it will mix. And this was already in URP, but it was pretty expensive for mobile. Even for HDRP, it was quite expensive. And we've done a lot of work at optimizing it to make it available on URP as first citizen. The second thing is you can now make a global volume in your entire project. So if you want your project to look good by default with the bloom and everything, because this is the way you want it to be set up, you can put it in the global settings. And on each quality setting, you can put an override, which will override some of these global settings. So it allows your scene setup to be much more lean down the line. And the interpolation is very efficient now as well. We also improved the simplicity to create a post-process effect with shader graph. We added HDR display support and HDR calibration template. I'll go fast on this one, because time is running out. We also added foveated rendering for XR. Specifically, we added the support for Forward Plus in Unity 6. So foveated rendering allows to render a higher density of pixel where you're looking and less pixels when you're not looking. If you don't have eye tracking, it will be at the center. If you have eye tracking, it's going to be on the side. And it will be available specifically for PSVR2 and PSVR2 and yeah. I think it's already used on. There is another system on Quest 2 at the moment, but the result is pretty crazy when you start feeding your like shading your pixels. On this test, for example, on the cockpit template, we go from 18 milliseconds without any foveation level to 13 milliseconds, which is huge on the mobile app. And then lastly, we really wanted to provide artists a much better tool set on URP. And it was a lot, you will see it's a lot of things. So the first thing are APVs. So adaptive probe volumes, that's something that we also introduced in 21 in HDRP. We got some feedback, production feedback, made it better in 22. And now it's available, it's production ready for everyone. It's also a nice way to land a feature, to start small and then until it matures and it reaches the wide audience. And basically what it is, so for global elimination, the cheapest way in terms of performance is to use light maps. But light maps are very slow to bake, even if now with the GPU Lightmapper, again, which is out of preview in Unity 6, it's much faster, but it's still a bit cumbersome because it's still, in general, quite long to bake. Number two, you have to have UVs on all the geometry which is affected. So usually you combine it with adaptive probe volumes for the small objects and for the dynamic objects. But the the light probes, did I say light probes? Or yeah, sorry. And you put light probes on top. But the light probes, you have to place them manually, right? And I don't know are there lighters here? You didn't invite, okay. I thought people didn't invite the lighters to the conference. But it's super cumbersome. And so APVs, what it does, it's much higher quality than the light probes, and which means that you will need less light maps or no light maps at all. So for example, in the demo that I was showing, thank you, that I was showing this morning, like the entire world is just light probes. There is not a single light map on this world, and it was a few minutes to bake the entire world, which is pretty amazing, right? The second thing is that it's not just placing probes automatically, but it adaptively places them. So, for example, it will place a lot more probes when you're close to a geometry and less probes if you're in an empty world. I don't know if you've seen this in the demo this morning. And then it's not totally automatic, it's actually controlled. So you can place density volumes and say, I want more probes here, a bit less probes there. You can say, I want touch-up volumes. I want to make sure that the probes are not going I want to make sure that they never go into this wall. And if a probe, by default, if a probe is inside of a wall, it's going to be deactivated automatically or pushed back. So it's really, really powerful. And then why it's better visual quality? Because it's per pixel lighting, which means that, for example, if you have an object composed of multiple pieces, like a car, with light probes, each game object is lit evaluates the probes around, which breaks the batching. And if you have a single sphere, it will have to choose between being red if it's close to the red wall or green, but it cannot be red on one side and green on the other side because there is no per pixel lighting. We also added per vertex lighting, which means that which is cheaper for the shader. So if you have a good homogeneity in your vertices, then you will actually have good looking for pretty cheap evaluation for the global elimination. And then what is great is now it's a single system, right? It's not like just probes randomly placed, which means that we have control on how we can stream them in and out. So the contract is very simple. You give your memory budget, and we just stream in and out the voxels which are too far away for you. It's very easy to stream if you have a larger world. And then, that's what I showed this morning also. Like if you have a game where you have a scene during the day and then a scene during the night, you have directly in the UX, you have baking sets. So you just add a baking set, you place your lights associated to this, you bake the second set, you go back to the first set, you edit, you can bake. So it just manages it for you. And as I was mentioning this morning, you can blend between them so that you can create time of days. So with about 12 baking sets, you can make a full time of day for your game. But sometimes you don't want to have to bake all this time of days. So we added sky occlusion, and sky occlusion is to store how much of the sun light how much of the, sorry, not sun, but how much of the skylight is coming directly or indirectly to a probe. And once you store this, it's very powerful, because when the sky is changing, that's what we're seeing here, you can just completely recompute automatically the global illumination without even having created multiple scenarios, because a lot of the contribution of a time of day is actually just the sky contribution. It's a very fast introduction to APVs, but there is a great talk at GDC if you want to check. So again, we improve compatibility. For example, VFX Graph, a few features were missing compatibility with URP, the decals, the smoke lighting, the motion vectors, and also access to the camera buffers now, which landed recently. The smoke lighting is this amazing thing where we offer you a pipeline to bake six-way light maps, so that when you create a smoke, for example, it will work during the night, during the day, it will be lit by the probes or by the lights. We've improved onboarding as well. Like I think our tools are really getting better and better. But for example, VFX Graph was very complex to use, and a lot of people were like, wow, I don't know how to start. And advanced people were like, oh, I missed this little feature. And we said we have to invest on making it easier to start. And so the first thing we've done, when you create a new VFX, you will have this window here, which gives you like the basic effects that most VFX artists are starting from. And this window, you can add your own templates to it. So when your VFX artist creates an effect, he can reference it as a template, and then the rest of the team can use it as a reference if they want to place and tweak it in the world. Then number two, we added learning samples. So if you go to the package manager, VFX Graph, you click on samples, you will see a bunch of learning samples where it showcases each piece of VFX, what makes like 90% of the VFX, and it explains you one by one how to make them. Then you can copy-paste these parts and put it into your effect. And the same for shader graph. It's very hard sometimes to understand what a nodes is doing. If you go in the samples, now you have a shader graph nodes reference, which is tons of shader graphs, which are explaining for each node how the mathematics are working behind. So it recreates with simple nodes like a more complex node, and it showcases examples of how what you can do with this kind of thing. So it's like even like for somebody who wants to make shaders, you just look at this and you understand everything, you have your ideas and you learn. We also, like part of, like we come from a world where as an artist, if you want to do anything, you need a developer almost. And even if we put like shader graph and VFX graph and more visual tools, there was always these little moments where it's like, oh no, I need to code something again. And so, for example, the shader globals was one of the ones that every artist was saying, why do I need to code something for this? I want just a table in the global settings, which is what we have now. So, for example, you were saying, Jonas, in the Oasis, right?
Well, for the transition effect, for instance, that's a value when you transition. It's like a normalized value, and that's needed by a lot of shaders.
Yeah.
So having that as a global would be very good.
Yeah, or like the wind, or if you have a fog system, you just want to control it in one place. One of the top requested feature for UI and for shader graph was to be able to have a shader graph node so that you can create a custom UI material. So it's really powerful. You can do your own blur and all these things. So it's really cool that it has landed here. So we also wanted faster iterations. So as I mentioned, the GPU Lightmapper, which is now pretty good. Like I talked with the ArcVis Pro, one of the ArcVis Pro creator, and he was telling me that he was only using the GPU Lightmapper, and he was saying, oh, but the memory sometimes is a bit big right now that it takes, and it's exactly what we reduced. Now you just need 2 gigabytes of GPU memory to be able to use a GPU Lightmapper, which on Steam it represents something like more than 90% of the devices. So adaptive raw volume, it's clear that it will be faster iterations, and something amazing, shortcuts for VFX for shader graph. It's pretty good. I don't know. There's no technical artist shouting. I'm surprised. Okay. So there are tons of shortcuts which landed. So yeah, we wanted to improve scalability with a resident drawer and occlusion culling. We will be just buttons that you turn on and it's magical, which is pretty amazing. And the APV data streaming that I mentioned. And improve visual fidelity thanks to the APVs for the dynamic objects. We also, it was a project, Remy is here. It's really nice. One of our QA had this kind of passion project to make screen space lens flare, so we let him go to the end. So now we have screen space lens flare for both URP and HDRP, which is super nice because it allows to create lens flare, for example, on reflections on the ground. It also like a one button so that you have lens flare on all your lights. So if you have a CD at night, for example, you have all this automatically for you. And you can choose between light streaks, very science fiction-y, and normal lens flares. We added URP temporal anti-aliasing. We also allowed new possibilities. So it's a little thing, but a lot of people were asking for it, that the light probes could be movable so that you can bake them in a, for example, in a brick of your world, and then move that brick so that it can repeat. So we added this, small detail, but it's here. Time of day, as I mentioned before. And improve extensibility. You know, like again, like when we are wrapping these 5 years of SRPs, we always end up in a place where you're like, oh, this VFX graph missing this functionality, you know, and shader graph had custom node. Now VFX Graph has custom HLSL nodes so that you can add your own functionality, which is good for voids, flux, and fluids, yeah, or any kind of simulation, or just if it's easier to write the code and not having tons of graphs like you showed before. Mm-hmm. And of course, we added custom post-processing, so you can do custom post-process with shader graph, and there are very good samples in the HDRP package if you want to take a look at them also. And finally, we are close to the end. Sorry, it's a lot of information. We added more optimization tool. This is the last part which was really missing, is the fact that we have tons of profiling tools, right, in Unity. But sometimes within your shader graph or within your VFX graph, it's really hard to know inside of that what is actually very expensive. You will very quickly know that this shader is expensive, but where? So now there is a shader graph heat map, which shows you with a color code which one is more or less, which part of the shader is more or less expensive, which are the expensive nodes there. And similarly in VFX Graph, you have profiling tools to give you memory and performance consumption across the VFX Graph. So a lot of things, right? So if you want to know more about URP, who goes to resources.unity.com here? Who knows? Okay, 1, 2, 3, 4, 5, 6, 7. Okay, you should all, in my opinion, you should all have this linked on your shortcuts because it's an amazing place. You have interviews with developers of games. You have interviews with the people who work at Unity who are optimizing the content for our clients, which would just give their tips. You have ebooks which are fantastic, giving like all the tips. We all participate in these ebooks, giving all of our tips. So really look at that. And you have videos, you have all the formats, sometimes 3 hours, sometimes 5 minutes, like a book and so on. Learn.unity.com. This is actually the Universal Render Pipeline ebook, which was released recently. And now Muse, if you want to have a conversational discussion about the things you want to know. And a lot of content also is available. So the new template, if you want to scan the QR code. And also I noticed, because I started product manager for URP, I don't know, 4-6 months ago, that actually we ported a lot of our tutorials to URP already. So like a lot of our demos that were made like even 5-6 years ago, 7 years ago, have been ported to URP. So there is tons of content to get started and assets to get. Thanks a lot for everything. And I think we don't have time for much questions.